Welcome to another session of Euclidean geometry, that is grade 11 cycle geometry. Now, what are we doing now? We are going to be applying the theorems that we have proved previously. Now, applying the theorems, you should be very careful, folks. Remember, I said be able to state the theorem, be able to prove the theorem. Number 3, be able to apply the theorem. Now, when you look at the given diagram, first of all, you must be able to identify the theorems that are going to help you to solve that. Now, let's look at this diagram. Do you see that they say center O is there? Now, they certify and assure you that O is the center of the circle. In that case, when they say O is the center, you know that the angle at center is twice the angle at the circumference. Number 2, look at this particular diagram. If you look at D, E, F, G, you can see that we have got 4 sides with vertices that are on the circumference of a circle. That means that D, E, F, G is a cyclic quadrilateral. Remember the 2 theorems that we have done up to so far. Opposite angles of a cyclic quadrilateral are supplementary. Look at FG being produced to H. Now, if you have FG being produced to H, you end up with the exterior angle, which is equal to the interior opposite angle of a cyclic quad. Now, that is very important. Another thing, you should remember that when we ask you questions, because geometry is all about trying to enforce or trying to practice the skill of logical reasoning for you to master. The questions that we are asking, the sequence in which we ask them is in such a way that the first one, the first answer, would help you to find the next one, and so on and so on. Look at what I mean there. Question 1.1, they say to us, calculate the size of LF. Now, we want to know what is the numerical size of LF. Now, looking at this, there is LF. There is my center there. Meaning that now LF being on the circumference of the circle and having another angle which is at the center of the circle, both of them being subtended by FG. That means this angle is half of that particular angle. Now, that is why I'm going to say here, let's say this is O1. Angle O1 is equal to twice angle F. What is the reason? Reason is angle at center is equal to twice the angle at circumference. Now, we know angle O1 is 227 degrees, which is equal to twice angle F. Now we want to find the size of angle F. I'm just going to make angle F the subject of the formula by saying 227 degrees divided by 2 which gives me 113.5 degrees. That is 113.5 degrees, which is equals to angle F. We have answered the first question. This angle is 113.5 degrees. Beautiful. Now, we move on to the next question. That is 1.2. Calculate the size of LD. I spoke about logic. Look at that. This helped us to determine this. And this is going to help us to determine that. It is like I'm playing soccer now here. Nigga, nigga, you pass, I pass, you pass, I pass. Now, what do I know about these two angles? I know from the theorem that opposite angles of a cyclic quadrilateral are supplementary. That is LD plus LF. They add up to 180 degrees. The reason is these are opposite angles of a cyclic quadrilateral. Now, we are looking for angle D. Let's make angle D the subject of the formula. That is angle D is equals to 180 degrees. We take this one to that side, minus angle F. Therefore, angle D is equals to 180 degrees minus 113 degrees, 0.5 degrees. And this would give us, again, I take my beautiful friend there, 180 degrees minus 113.5 degrees. I get 66.5 degrees. 66.5 degrees, that's beautiful. Now that angle is 66.5 degrees. To the next question. I must say that even though I said logic, nigga, you don't have to always pass the ball. When you see that the ball posts are in front of you, you have got a chance to score. You score, you can't pass the ball back to your opponent. What do I mean by that? Not every question will depend on the logic or the answer above. Some would be independent so that everyone can be able to score marks even if they don't remember the above theorems. Look at the next one. They say, what is angle E1? Let's look at angle E1. Angle E1 is that small, beautiful angle there. If you look at it, we have a big angle E1 plus angle E2. That is why I'm going to start by saying angle E1 plus angle E2. What about those two angles? They are exactly the same as angle G1. There's G1 there. Angle G1. How do I know that? I have got the cyclic quadrilateral with this line produced to that point. Therefore, this means that the exterior angle of a cyclic quad is equals to the interior but opposite angle. That's beautiful. Now I want angle E1. Angle E1 would be equals to angle G1 minus angle E2. And the values are angle E1 is equals to angle G1 is 110 degrees minus angle E2, which is 67 degrees. Therefore, angle E1 is equals to, now, here, I'm becoming a bit lazy to use my head. That is 43 degrees. Now, we know that this angle is 43 degrees. Did you see how easy it was for us to find all these angles? Because we could state our theorems, we could recognize them. Now, for you, I would also say be able to state them, be able to recognize them. If you want to be able to state them, always sing these theorems daily before you go to school, before you go to bed. That is what I always do. Also, I've got my guitar here. I sing them. Let me sing you one. I'm signing off. I'm saying ding, ding.